In the following simulation, we will observe how the electric current and applied voltage correlate with the electron model of the photoelectric effect. So, electrons carry an electric charge, and the movement of electrons between plates in a photocell creates an electric current which can be detected by meters outside the photocell. If we switch on the lamp, we can further observe the electrons moving between the plates of a photocell, where apparently the electrons escape from the lower plate up to the upper plate. Next, we move the applied voltage slider to the right to apply positive voltage to the plates. This turns the upper plate positive and the lower one negative, so that emitted electrons experience an upward force of attraction. The graph that appears shows a current voltage curve. At voltages close to zero, some electrons miss the upper plate. Then a small increase in voltage boosts the electron pathways towards the upper plate. Then more electrons reach the upper plate during each unit of time, so the current, which is the rate of moving electrons, increases and thus becomes larger. Once all available electrons migrate to the upper plate, any further increase in applied voltage does not increase the current above its maximum value. Therefore, the curve line reaches a plateau region or a constant horizontal region referring to the maximum current reached.